Hey everybody, welcome back. Just a reminder, we are in Unit 5 functions. Ignore the fact that there's a 3 here. This is just lesson 2. We switched up the order this year. So we've been looking at relationships between two numbers. We made a mapping diagram, tables, graphs. Now we're going to decide if it's actually a function. There's a couple things that need to happen. So one thing I've found helpful in the past is remembering this sentence right here. Each person can have only one birthday, which makes sense, right? You can't have more than one birthday. But instead of using the word person and birthday, we're going to use X to represent the person and Y to represent the birthday. So now if I take this out, each X can have only one Y value. Right? You can't have more than one. So on a mapping diagram, if you see something like this, if you see 3 going to 1 and then going to another output of, say, 5, that's not okay. That's not a function. Because 3 is basically, again, your X is your person. So this person is saying they have 2 different birthdays in January and May. But it is okay if you see person 3 has a birthday in January, but person 4 also has a birthday in January, that's okay. So look at the difference between those. If you see an X value that goes to 2 different Y values, it's not a function. But if you see 2 different X values going to the same Y value, if you see 2 people with the same birthday, that is okay. That is a function. All right, so let's look at a couple examples with this to hopefully make a little bit more sense. So let's actually use children and birthdays. All right, a person and a birthday. So here, your function is the input, your X values would be, I put a name. Think of the function like a machine. I put the name into the machine, and the function would be, what's the birthday month? And out pops the birthday month. So Max has a birthday in January, Evan in April, and so on. It says, why can we consider this a function? That means it is a function because each person only has one birthday. If you saw Max sneaking in at the bottom saying he's got another birthday in June, then that's not a function. So why can we consider a function? Each child has one birthday. Only one birthday. And again, if you take out the word child and birthday and replace it with X and Y, each X has only one Y. All right, what's the output when the input's Rosie? That's just another way of asking, what's Rosie's birthday? We'll find Rosie over here, February. Find all inputs that have an output of May. So find all the people that have a birthday in May. Zeke and Nico. And again, that is a function. Even though, it has not really math related, it is a function because each person only has one birthday. But again, it's okay if 2 people have the same birthday. All right, on a graph, I think it's the easiest to tell if it's a function or not. It must pass the vertical line test, or VLT. If you draw a vertical line, which remember is straight up and down, anywhere on the graph, it can only intersect once. Just like it could only have one Y value. It can only have one birthday. If it intersects more than once, it's not a function. So let's see if I can turn off my pen here and make it so that I can drag this along. Maybe not. Okay. Well, I tried. So if I were to draw that line anywhere on here, let me change up the color. If I were to draw a vertical line anywhere on here, it's only going to intersect once. It doesn't matter where I draw it. Same thing on this one. I can draw it here, here, here. It's only going to intersect it once at a time. Same with this one. I could draw it here. It's only going to intersect once. If I move that over, it's only going to cross once. But this one right here, if I draw a line right there, doesn't matter where, if there's even just one place where you draw it and it intersects more than once, it's not a function. And that's it. So if you do, it can be the funkiest looking graph, but if it only intersects once, it's a function. If it intersects more than once, it has 2 birthdays, 2 y values, so it's not. All right. So let's look at some different representations of a function or of a set of relations and see if they're actually a function or not. And it says explain. So does this one look like a function? Let's see. Does every person have just one birthday? Well, this is okay. Right here. Like these are fine that they're both going to the same. But this guy right here, you cannot go to 2 different y values. So it's not a function. -1 has 2 outputs or 2 y values. What about this one? Oh my goodness, 1 and -5 are breaking the rules. So 1's saying it has 2 birthdays and so is -5. So that's not a function either. 1 and -5 have 2 y values. Can only have 1. What about this one? That one's fine. Again, think of this as person and birthday. They both have a birthday in January. That's fine. They both have a birthday in February. We're good. So that is a function. Each person, each X, has only one birthday. But instead of birthday, we'll use Y. So each person X has only one birthday, Y. Each X has only one Y. So you're good. All right. Sometimes it's hard to tell looking at a set of points. So if you want to, you can create a mapping diagram to help you explain. Or you could just look for the same X showing up more than once. But when you're getting started, I think it's easier to do a mapping diagram. So 3, 4, 6, 8. I already see that none of my X's repeat, so that means that it's going to be a function. But let's just see it visually. Sometimes that helps. 4, 5, 7, 9. So a little practice from yesterday. 3 goes to 4, 4 goes to 5, 6 goes to 7, 8 goes to 9. All good. It's a function. All right. Right in this next one, I see 3 goes to 4, but then it shows me 3 goes to 9. So I already know that it's not a function. Okay? 3 has 2 y values. Again, if I draw that, my domain is 3, 4, 6. My range is 4, 5, 7, 9. Same range as the last question. All right, 3 goes to 4, 4 goes to 5, 6 goes to 7, but then 3 goes to 9. Can't have that. All right, what about the last one? -2, -1, 1, 2. Nothing repeats. These go to the same y value, but that's okay. All right, it's okay that they have the same birthday. So this is a function because each X has only one y. Again, if you wanted to, you could draw a mapping diagram and you would see that none of these go to more than 1. All right. So let's take a look at the next one. 3, 4, 6, 5. I see 2 4s here, so it's like, But remember, the y value represents the birthday. 3 has a birthday in March, and 5 has a birthday in March. That's okay. It's a function. Each X only goes to one y. Again, if you want to see it, 3, 4, 6, 5. That's your domain. 4, 5, 7, and then 4 again. I'm not going to repeat it. I'm just going to use more than one arrow. 3 goes to 4, 4 goes to 5, 6 goes to 7, 5 goes to 4. That's okay. That's fine. All right, but on this last one here, 2 goes to -3, but then 2 goes to 1. Not a function. All right, 2 has 2 y values. Can't have it. Sorry. All right, and then the last one, is each graph a function? Again, these are my favorite. I can draw a vertical line anywhere on here. It's only going to cross once. So yes, that's a function. It passes the vertical line test. This one, I can draw a line right here. It's going to cross twice. So it fails the vertical line test because it crosses twice. So not a function. All right, for practice, I would like for you to do page 6. All right, so you're going to take this mapping diagram, make a table, and plot the points. I'll fill in the rest of the table, I should say. Tell me which of these is not a function and explain why. Okay, use your vertical line test. And last but not least, tell which one is a function. It might help to make a mapping diagram so you can easily tell. All right, if you have questions, stop by my virtual math lab or send me an email. Have a great day.